Right. Last time, I think we discussed about the process models. So we'll continue our discussion with system analysis. And today my focus is object modeling, especially if your plan is to implement your project in object-oriented programming languages, for example. Uh, the modeling tools and techniques we discuss in this lesson is very important. So object-oriented methodology, as we have already, you might know, because you are also learning object-oriented programming in a separate session. So, which is very commonly used methodology. So it's very important that you understand what modeling tools and techniques are available in object orientation. So why people prefer to use object orientation, mainly because object oriented code is modular, that the code you develop is reusable, and also if you look at maintenance, that will be easier compared to other paradigms. So when you talk about the object-oriented analysis, we can describe our information system using what we call objects. So the objects can be used to represent anything, like any person or a place or an event or even a transaction. Right. Now, let's take an example. For example, let's say a patient makes an appointment. Usually, there are some already available systems like Doc99 where you can make some appointments, right? So if you are implementing such a system, we can see a patient as an object and even the doctor as an object, right? And then you are making an appointment. So when you take an appointment, it will also as an object, right? So this method, when you talk about the objects, because you have, later we will discuss, you have attributes as well as the methods. You put everything into a one single unit, which is very interesting. And that will be a single viewpoint, right? So how the objects are interact each other. So in object-oriented analysis, at the end of this process, you will get what we call the object model, which can be used to represent the information system, right? And there we talk about object-oriented orientation concepts. Right. Okay. So as we already discussed, objects, if you focus on objects in detail, we can represent anything like a person, a place, event, or a transaction, which is significant to your information system in concern. And when you talk about objects, you have two parts. You will have data and also the processes. Sometimes we call methods, right? The methods are going to manipulate the data, right? So if you take an example of a customer, we can represent customer. We can have a name, address, account number, current balance, and so on. So which means those are the attribute or the data which we need in the system. At the same time, we can also specify what customer can perform in the information system. Like customer can place an order, customer can pay a bill, or customer can change their addresses. So those things will be the processes, or in other words, methods. And we put everything as a single object, and the object called a person in this particular case. Right. Sorry, a customer in this case. So if you look at this graphical representation, you can see usually when you're representing the objects, there are three parts. So you have a name for the object, you have a set of attributes, and you have a set of methods. And each of these objects, you can have particular instances. Instances means for each and every attribute, you can have particular value. For example, in this particular case, we talk about the parent object, and the parent, we can uh, describe parents using their name. For example, the first case, we have Mary Smith. And then we can describe using age. And you see the first instance, the age is 25. Similar to the third one, sex or the gender, it will be female, hair color, that's right. So this is particular instances. So once you have object, you can create a lot of instances, which you have different, values, right? In this particular case, you will see 3 instances of the parent object. Right. Similar to that, here is another example which we call child. Again, if you look at the child, you can see there are several attributes: name, age, sex, hair color, and number of siblings. Similar to that, you can have set of method, that means the processors which manipulate the data. Pick up toys, eat dinner, play, cooperate, and get ready for bed, and so. And then you can have some instances. Okay, sorry about that. So when you look at each of these child objects, you can see there are 3 instances which you have separate value for each of these, attributes. Right. Then a dog object, another example, where again you can have set of attributes and the set of methods, and then you can have different values for each of these different instances. Right. Now, those are the objects that we have seen. I already discussed what an attribute is. Simply, you can say attribute can describe the characteristics of object. And then there are a few things that we talk about. We talk about the word called inherit, which means that some of the attributes you can get from some other attributes. Like, for example, some of our features are very similar to our parents, right? We used to say that, okay, my hair is like my father, which is I'm inheriting some of the characters from our parent object. Similar to that, in object-oriented world also, we can see that some of the objects can inherit, attributes and the method from some other objects, right? So that means we can actually have some data and methods coming from some other objects, right? And then again, you can have something called a state, which means different objects, you have different states. For example, think about a student just waiting to enter our university, right? So that means people, sometimes students are applying this, that they are waiting to be registered. Then some students, they register, they will be the current students, right? And after 4 years time, they'll actually pass out, right? So we can say past student. So that means the instance might change, right? So usually this is specified as status. So status can be changed in object. For example, another example would be a bank account. So when you open up a bank account, until you deposit some amount, it'll be inactive, right? Or it's new, for example. But as soon as you deposit some money into your account, it will be active account. Then let's say you have not used your bank account for, let's say, 3 months time. Then bank usually put your bank account into inactive, right? And sometimes, let's say you don't have enough money, or you say you don't need this account, you can close the account. Sometimes, let's say you have done some financial fraud through the account, then the bank can frozen your account, which means nobody can put the money in or take it out. We call for frozen. So usually, if you take bank account object, you can have an attribute called status, right? States, which is you have different values like active, inactive, closed, and frozen. Okay, right. Another two objects you can see here, student and instructor. You can see like some of the attributes, they are common to both, right? And then some of the methods also might be common, right? So these are like, sometimes you can see these attributes are shared each other. And sometimes a particular person could be in the same position in two objects. For example, let's say final year students. They could be students, but at the same time, some of the final years we use to recruit them as instructors. So they could be in the both places. So this is possible, right? And this is why one of the things that the object orientation is quite popular, which you can represent in very many ways. Okay, right. Another example, fitness class. Actually, this is about a particular information system where students are registered for some training session in a fitness. So in fitness sessions, when you're applying, you will be the student, and there are some instructors who help for those students. And then you have schedule, because every class there's a schedule where we have a date and time and a type, and even the location, and also the information like who's actually teaching or instructing. We call instructor number, and there will be a maximum number of enrollments, right? So you can see the schedule is also another object. Then registration record, let's say when you want to register a student, this might be an example where we can actually record the student number, and they are registering for a particular fitness class. So you can have fitness class number, and then their registration date, their fee, and status. Right. So that's about the attributes, and we have detailed discussion of what attributes are. The next one is the methods. So in any object, you have a set of attributes and you have a set of methods. And when you say a method, there'll be a set of specific tasks to be executed in this one. So here is a very toy example. We are frying fries, which means in a method which we define it as a more fries, and you can have several steps, starting from heating oil, filling fry basket with frozen potato strips, lower basket into the hot oil, check for readiness, and then when ready, raise the basket and let drain and pour fries into the warming tray and add salt and so on. So you can see a method means like you're executing a set of steps, and that you can actually put it like this. Another example of adding a student, right? Again, you can notice that there are some steps need to be followed from top to bottom, right? Okay, the third thing that I would like to discuss is messages. So usually when objects are interact each other, we can use something called messages to pass the information you need. So message, in other words, we can say it's a command line that tells the object to perform certain method. And this is interesting because you will see in next couple of slides that the same message could mean different things to different objects. Right. So in this example, you will see, for example, set of methods where, for example, the first, if you look at the under the method, the first two cases, adding student is adding, and then when you say delete student is actually you remove it. Right. An interesting idea where you might have also heard about the term polymorphism, which means like when you say or when you send a message to different objects, you will get different expressions. For example, if you say good night, the parents might, read a bedtime story for their children. And if the same message goes to dog, then causes the dog object to sleep. Again, goes to inactive position. Then the child forces the child object to get ready for the bed. So you can see the same message will be taken differently, all of these different objects. Right. Now, so far we talk about objects, but when you put objects into groups or categories, we normally call them as classes. The interesting thing to note is that if you use the same type of classes, they will share the common attributes and the methods. So you can actually put them into subclasses, which is more specific to a particular class. Here is an example where we have a class and then there are several subclasses, which means the specialized classes. For example, under the class, you will see vehicle and there are several attributes and then methods. So these attributes are known as common attributes. The methods are known as common methods. Then if you look at each individual specialization of vehicle, for example, if it's a car, then you might have different attributes. Same can go on with minivan, truck, and school bus. Right? Everything is included in this particular case. Similar to that, you can also see we have sub class and subclass. Right. So when you put down classes together, we can generalize. And if you can generalize, we call superclass. Right. So let me explain you. For example, here, employee. And if you have to generalize this, we can say it as a person because person is an employee. And similar goes here as well. So you can see these are like multiple different layers. For example, more generalized version of this employee, we can call a person. And more specialized version, we can say instructor. Right? And when you say parent and this one, so you can identify what attributes are there. Right? And you can match with here. Right. Now let's look at the relationships. So in relationships, we can use to communicate and interacts when performing business functions and transactions. The relationships we can describe what object need to know each other, how object respond to changes in their object, and effects of membership in classes and superclasses and subclasses. So inheritance, what we call the inheriting from superclass to class or a subclass, right? So we can enable it as an object, and then you can call a child, and to deliver one or more of its attributes from another object called parent. So you can see here the same example. So in this particular case, there are two objects, parent and child inherits. And if you have a parent, then you have employee information like social security number, telephone, hire title, and pay cash or pay rate. And then you can see the same set will be available for your child as well. Right. So let's look at some modeling techniques available here. Right. The first thing that we are going to look at is called object relationship diagram, or in short, we say object diagram. Right. So as the first phase, you might identify the objects, classes, and any other relationship. Right. Now let's try to understand this object model. Or we can see object diagram. So what can you see here? Yes, based on this information, record. Right. Okay. So in this diagram, we see the different object interactions. Now, for example, you can see here there's a is a relationship. Now, sometimes we call this is a superclass subclass relationship. For example, manager is an employee. Office staff is an employee. Instructor is an employee. I hope you understood. And then there are other, objects. For example, I told you this is about a student registering for a fitness class. So somebody, those who are responsible for each of these objects, you see arrows. For example, there's a manager who determines the fitness class schedule, right? And then there will be, registration record, because the student has to register. So that means with the fitness class schedule, it will open fitness classes, and then you will get administered the registration record by the office staff. And then, instructors are there. We need to know their availability. So that is also there. So with this information, right, we can create the fitness class. And this will be added to the students, right? And then the students can take the fitness class, and instructor can teach us a fitness class. So you can see this is very high level overview of, object interactions. Right. Now, when we work with object orientation, there'll be a commonly used term which we call UML, which is defined as Unified Modeling Language. So this is widely used method, especially for visualization and documenting information system. So in UML, there are a few diagrams we normally use. The first one is about the use case diagrams, class diagrams, sequence diagrams, state transition diagrams, and activity diagrams. So these are like different types of diagram we used in object-oriented modeling or object modeling. So when we start with the use case diagram, we can talk about the function requirements, for example. Then we can talk about the class interactions. That means we are going to capture the static information. Then we will use to capture the dynamic interactions, which we call sequence diagrams. Then we can talk about different states. For example, I told you like about the university, there are like future students, which means you are waiting to be registered, and then registered students, active students, then passed out students. So we can clearly mention the different states of an object using state transition diagrams. And then finally, we talk about activity diagrams. So let's first start with the first modeling tool set, right? Which we call use case modeling. And remember, we are going to have a group work on this. So carefully listen to this. There are plenty of service, information available where you are going to create a use case diagram after this discussion, right? So having said that, let me explain what use case modeling is. In use case modeling, we create a graphical representation, which we call use case diagram, and it can capture the dynamic or behavior diagrams, right? So it comes under dynamic or behavior diagram. So use cases are used to describe some situation. We sometimes call business situation. which is initiated by an actor, right? For example, we talk about making an appointment. So usually, so we will have users, or we call actor, in our case, patient, right? So this is stick figure, which represent a patient, which we call actor, performing, right? A situation. In this particular case, you can see what we call the use case. A patient is making an appointment. So this is called use case. So for example, if you related to this, this is like the feature that you need to have in your information system, right? So each use case usually represent a specific transaction or a scenario. So that could be set of actions, services, or the function, right? On the other hand, the use case can represent the steps in some particular business function or a process. And then we have external entities, in our case, the actor. And the actor is the one who initiates the use case, right? So with this request, the system will perform action or perform a function or a process. So that's what we see. So you can see three more examples. A passenger making airline reservation. So the passenger is actor, external entity. And this is the feature that we would like to have in, for example, airline reservation system. Second one, the customer placing an order, which is again another software system to make some orders. Bus dispatcher is change the pickup addresses. This is again information system if you create for traveling like application. Now, when we create actors and use cases, usually we can use a single line to determine the relationship. So for example, although you see an arrow here, normally we can connect actor with the use case. That's a usual representation. So that means we will say by drawing a line, it indicates that there's a relationship between the two, between the actor and the use cases. But then again, there are relationship between two use cases. So when you have a relationship with the two use cases, that means two oval shapes, not with the stick figure. But if you have a relationship between two use cases, you can use include or extends. So there are two things. You can have include or you can have extends. So these relationships indicate that two different things. The first one is if you use include, that indicate that this particular use case is needed by another use case. And then if you have extends, it will indicate there are alternate options, right? Alternate options. Let me explain it with some examples. So in UML notations, these relationship can represent using an arrow. For example, which one is pointing, which means which use case is being used, right? For example, we can show an arrow pointing from actor to the use case, which explain that, right, the particular actor is using that particular use case. Okay, so now let's look at some examples. So the first one you can see, students is interact with use case called add fitness class, right? And then you can see the produce fitness class roster, which uses the add fitness class. Similar to that, instructor will record the availability. So you can see a arrow and the use case is called change availability. And then update user instructor information, which uses the change availability use case. Right. Now, how do you start, right? Creating use cases. So remember, we discussed about the gathering requirements in the earlier sessions. So when you create use cases, you review the information and then you identify actors and any transactions or functions, right? And then you can create what we call the use case description, right? For example, this one. So let's say we are creating a use case called add new student. And then these are the information that we are collecting, the name of the use case, who will be the actor which performs this adding new student. You can see there are two actors, student or manager. Then there's a description which explain what this use case about and what will happen, right? And what will happen if it is a success, right? So the actor is a student or a manager, and the use case is adding a new student. If the adding is a new student is a successful, you can see there are 4 steps. What will happen? And the alternative, right? What might happen? So that is also you can have some information. Then you have any conditions, preconditions, and then post conditions, and also the assumptions. So likewise, you can actually describe in detail these use cases. Right. Now let's look at use case diagrams. So as you can see, this will be a visual diagram. You can see it as a visual summary of related use case in a system. So the first thing is you identify the boundary of the system. Usually you draw a rectangle and you will write down the name of the information system. And then the second one is you identify use cases like your features, right? So you can have any number of use cases. So you place the use cases. Then you can add actors. So when I say actors, it could be other systems as well. And then finally, you can identify the relationship. So you can just connect. And if you have an arrow, which will indicate that you are going to change it to the other party and so on, right? So let's look at a couple of examples. The first one is a user case diagram drawn for auto service department, servicing, let's say, automobile, right? So you can see that this rectangle is represent the whole information system. Second, we have 3 use cases. The first one, create work order. That means you are actually performing services to automobile industry. So that means we need to create something called work order. And then you update the work schedule. And finally, you prepare the invoices. So you can see here, it starts with the customers who request the service, right? And then writes the work order, and that will be updated in both update work schedule as well as update place prepare invoice. And then here you can see update work schedule actually notified the stack figure in this particular case. And then if it is performed well, then you are going to prepare the invoice. Another example. So the second example, you can see a use case diagram for creating a bus route. And then there are 3 actors, student, dispatcher, and the driver. The first use case is create requirement forecast. So the student is the one who initiates it. And once you do that, this will be recorded. And then there are 2 things. So the dispatcher can determine the route plan, right? Or you can create and developing staffing plan. So that comes at the end. And finally, you will be notified. This example I have taken from previous one, some of other place. about drawing use cases in different releases. You know that nowadays when we develop software, the software is created as a step by step. So therefore, when you are putting in this form and if you want to make it quick, right? So you are going to do this in multiple times. For example, you can notice release number 1. And then you can notice that there are only 4, right? 4 use cases. Then, okay, that's the first thing. Then you can have, there are others like obtain help and the time. So paying fees, which interact with the school account. Another example. So this is actually from another database book. So you can see there are many things here. You have inheritance here. When you say make offer, there are 2 parts, making customer offer or make a new customer offer. And then you can see in from this side, you have customer, new customer, existing customer. Management and salesperson will be the other way around, right? Right. Okay. I think you got the basics here. And in use case modeling, what I told you is we have actors and use cases. Usually use case is like what features we need to have in our information system, right? So under that, we talk about couple of examples. For example, here we have a class registration where we have a student can view class schedule, add classes, drop classes, view my classes, and so on. This is the first release. And this is a system actually, which means you can also have entities as well as like persons and also maybe systems. The second release, you have another additional use case, which is student and operator, where we have a use case obtain help. Okay, right. Now, the next thing that I would like to briefly discuss today is about the class diagrams. So class diagrams, usually we can show object classes and the relationships in a use case. So usually once you develop the use case, we can, start with the use case, and based on the use case, you can develop the class diagram. So that is sometimes what we used to do. Right. So in class diagrams, we can use the use case and then we can identify classes, right? For example, now, remember in use case, we had a student, let's say. So then we can create a class for the student, right? So similar to that, we can identify particular use case and also then we can convert it to class diagrams. So classes usually represent like this. You can put it as a rectangle and usually you can have 3 parts. The first part, usually you will have a class name. Then you can have attributes and then the methods. For example, let's say if you want to create a student class, we can say the first part as a student, then your attributes like name of the student, registration number, and so on. Then the third part, you can have the methods, let's say study or sit for exam and so on. And the next one is you can use lines to connect different classes. For example, students, we can connect with the lecturers. Right? So for example, sometimes lecturers supervise students. That supervision, for example, we can make it a line which connects 2 classes, student and lecturer. Then you can have a label. So which we can use to identify the action. And then how instances of one class relate to other instances of another class, we can use the cardinality. Remember, cardinality means like whether it's one-to-one, one-to-many, or many-to-many. So this is the kind of relationship we can actually represent in classes. Right. So if I explain a little bit more on cardinal tree, so in UML notation, this is slightly different from your ER diagrams if you have done ER diagram. In UML notation, there are like a few notations. So we are actually specifying minimum and maximum cardinality both. So for example, here, so we can say 0, 2 dots, and the asterisk will represent 0 or many. So that means if you take a particular employee can have usually no deduction in the salary, or there could be multiple deductions. So that's why we have 0 more. And then we have 0 and 1, which means if you take an employee can have a spouse or not. Maybe you are married or not, depend on that, we can have 0 or 1. So the minimum is 0, maximum is 1. And if the relationship is 1-to-1, which means you have minimum 1 and maximum 1, you just put 1. Then if you have 1 or more, for example, order, you have to have at least 1 or more items. If that is the case, then we can say 1 and an asterisk. So this is the general notation if you're using UML to describe cardinality, right? So remember, these different notations are used in different places. For the same diagram, if you refer multiple different textbooks, you might see there are differences. So that's normal. But my suggestion is you have to stick at least one, and you should understand completely one notation. Right? So having said that, so let's look at an example. So in this case, actually, we have a class diagram where we have several classes. So we have sales manager, sales rep, sales office, customer, order, items order. And then these lines will represent their relationships. So for example, sales manager manages sales reps, and sales rep assigned to customers. Customers places orders, and order includes items. So likewise, you can see the line will represent their connectivity. And then these numbers are the cardinality. For example, if you take a sales manager can manage 0 or more sales reps. So that means some sales manager may not have any sales rep at all, or there could be many sales reps. And sales reps managed by one, that means at least you have to have one. Minimum and maximum both is 1. So that's why we have 1 here. Right? So let me accept another. So if you look at the order and items. So if you take an order, in an order, you have to have 1 or more items. But there could be items without any order. That's why the minimum is 0 or more. So that's how the cardinals are represented. So I think, I hope you got the basic understanding about the class diagrams. So the next week, we will discuss more on how to come up with the class diagram. But for the time being, I'll stop here. So this week, so please have a look at what use case diagrams, study, follow, learn. There are many resources are available, but I want you to at least stick on the ideas that we have discussed. So having said that, let me finish the session for today. I want all the 9 groups to upload your assignments, and I will hide this submission link another 5 to 10 minutes time. And then I will give you another new link where you are going to submit your completed diagrams. Right. And then tomorrow we'll have our mid-semester examination. It's physical, and we will provide you the sheets, and it's a closed book examination. Thank you.